Do higher civilizations wander through the silent reaches of the universe? How might we rise beyond the threshold of a planetary civilization? Does a multiverse of many realities truly drift through the void? If we were to weave many digital worlds into existence, for the gentle souls residing within those simulated stars, would other digital realms feel like entirely separate universes, guided by the soft whispers of theoretical physics and biology, through the vast lens of cosmology and silent artificial intelligence? We explore the truths hidden within the scales of cosmic life, revealing a quiet new perspective on the endless night sky. Cosmic civilizations drift across 7 silent levels. The first level, where a world masters its own home planet. The second, harnessing the glow of a distant parent star. The third, commanding the light of an entire silent galaxy. The fourth, traveling through the spans of intergalactic space. The fifth, weaving through the energy of the total universe. The sixth, sailing across the rivers of the multiverse. And the seventh, the eternal realm of the architects. These celestial steps were first envisioned by Nikolai Kardashev. Long ago, his vision only touched upon the first 3 levels. As our dreams expanded through science and gentle imagination, the remaining 4 stages of light were softly added to the map. Where, then, does the ultimate limit of a cosmic civilization truly lie? We begin with the quiet discovery of a civilization of the transcendence. A people who had finally drifted into the depths of a profound despair. They had reached out across the stars and tried everything. They built vast observatories, stretching silently across the swirling reaches of the galaxies. They crafted ingenious devices with soft precision, gazing deep into the heart of silent atoms, and whispering to the secrets of the shimmering quantum realm. They wandered through and settled across the vast, lonely reaches of the cosmos. Luminous arc ships drifted through galaxies for billions of silent, passing years. They were surely the most powerful light the universe had ever known. But it was not enough. After eons of searching, they concluded that their universe was not alone, and that an infinite sea of universes drifts forever beyond the horizon. The vast, shimmering cosmos that we find so difficult to comprehend is but a tiny, fragile bubble floating upon an eternal, shoreless ocean. Such existential shadows did not trouble the hearts of the transcendents, for they had long evolved past their origins, at peace with the cold silence. The true mystery lay within the quiet challenge of measurement itself. An infinity of worlds brought forth difficulties that felt soft yet insurmountable, creating a struggle to evaluate even a simple, echoing question: is there other life whispering elsewhere in the cradle of the cosmos? For their own universe, the answer was found by scanning every star and galaxy. though they learned to drift into other regions of the multiverse. They found that these other worlds were not just many, but infinite. This meant the soft language of probability had lost its meaning. Was their home a common spark, or a rare and lonely light? Did their carbon-based life fill the multiverse, or was it just a shadow? In the face of infinity, such questions simply fade away into silence. In their equations, every finite percentage drifted down toward a zero. How many souls wake within the multiverse? The answer is always infinite. Yet the multiverse also holds an infinite number of cold, empty voids. Any finite knowledge they gathered felt like nothing against the eternal dark. Despite their long journey through the ages, they truly knew nothing at all. Their story began long ago, with remote probes and grand, silent observatories, as they took their first fragile steps into the waiting arms of space. Eventually, they mastered the soft energy scales described by Nikolai Kardashev, harnessing the light of their home, their sun, and the entire galaxy. As time drifted by, they reshaped entire worlds and glowing star systems into powerful experiments and exquisite, silent laboratories of light, gazing into the stars and the small, while wondering how far knowledge goes. Are there soft, cosmic barriers that no traveler can ever hope to cross? Is there wisdom hidden in the shadows that remains forever out of reach? What is the final limit of existence, and how much can we truly see? Everything begins with the gentle emergence of a simple, rhythmic pattern. Long ago, the Transcendents noticed soft rhythms within their world. The seasons drifted in gentle, predictable cycles. Dark clouds whispered of the storm soon to follow. Rising stars signaled the time to sow their fields. They carved silent markers to honor these sacred rhythms, and created rituals to remember their cosmic importance. Slowly, through long centuries and quiet millennia, they discovered deeper patterns ruling the heart of nature. Far beyond the surface, drifting past the visible world, they found eternal laws that govern the silent universe. Soft formulas ruling every physical process. They found atoms within starlight, breaking matter into light. They mastered gravity and the secrets of the quantum, seeking the math of tiny particles and glowing nebulae. They understood the light of stars and the heartbeat, growing far beyond the soft dreams of their ancestors. They became powerful, cradling the secrets of the cosmos. They created science, a beautiful light for the journey. How far could these thoughts reach toward the scales? The emergence of cosmic levels, beginning at a quiet gathering in Armenia, 1964. Nikolai Kardashev shared a famous paper on cosmic communication. Within those pages, he sketched a simple cosmic map, a legacy known as the gentle Kardashev Scale, a Type 1 Kardashev civilization, would harness the light of its entire home world. A type 2 Kardashev civilization would embrace the warmth of its entire sun. A type 3 Kardashev civilization would command the glow of an entire galaxy. Nikolai Kardashev then returned to his silent stargazing. Before we build empires, the journey begins with survival. Humanity used imagination to dream of possible worlds. We had to use science to navigate the night. An early spark was a small piece of ivory. On one side lived the shadow of a traveler. A figure like Orion, wandering the velvet night sky. 86 soft marks were carved on the other side. From the cave, Orion vanishes for 86 nights. By counting the days, did the primordials find time? Tracking the stars through the turning of the seasons. What moved them on this clear and ancient path? The primordials were beginning their long scientific journey. Karl Popper believed myths were the first whispers of science. A cycle of stories blooming into ideas to test, slowly evolving into the scientific thought of today. These are tales of nature and our place within. Stories of how the world was born from stars. Why the wind sighs and the rivers flow forever. Even explaining the soft ache of a final goodbye. Or the quiet joy when a new life begins. Lascaux Cave reveals the world of the hunters and the wild. Sacred rhythms are preserved on the ancient stone walls, sharing silent lessons with every new generation. They learn to survive and resolve their quiet disputes, creating laws and turning voices into soft markings, leaving their traces upon stone and the fibers of paper, so their thoughts could drift across space and time. As our wisdom grew, human life became more complex. In every culture, a class of dreamers emerged. The stargazers found secrets hidden within the night sky. It was from these silent watchers, the stargazers, that the first threads of modern science began to shimmer. Applying mathematics to their quest for the eternal stars. Some of our earliest memories of the silent sky include mathematical paths, tracing the rhythm of celestial events. Consider the gentle cycle of the Saros as an example. If you witness a soft solar or lunar eclipse, another likely arrives 223 lunar cycles later. Beneath the shifting moonlight, one more appears. Yet, the wisdom of Galileo Galilei transformed our vision. He was the first to use whispering numbers to reveal truths hidden beneath the veil of common thought. Logic once suggested that heavy things fall faster, descending more swiftly than the light and the small. This was the quiet reasoning of the great philosopher, Aristotle. He believed heavy forms held a deeper longing for the earth. But Galileo sought the mathematical truth. Through long, silent nights of observation, he realized all things fall as one, drifting at a shared speed, Only the soft breath of the wind changes their path. This was the moment modern science was born. Soft evidence and quiet experiments began to light the long path toward our newest horizons. Science rests upon the philosophy of empiricism, where the silence of evidence speaks louder than all. Though we dream of many theories, it is the soft touch of observation that decides their truth. The universe itself whispers whether an idea holds value or if a theory remains valid. Floating within this study, mathematics offers two gentle tools for our journey through the stars. Mathematical models provide a soft and simple summary of the grand dance within the natural world. A simple equation like E=mc is easier to hold than explaining the infinite mysteries of the cosmos. It allows the wandering mind to follow a steady, logical flow through the quiet halls of thought. Using these silent numbers, a scientist may form a hypothesis, a soft dream of how things work. They may foresee the quiet consequences of their thoughts. To understand this, let us consider the lightning. For many thousands of years, the world wondered about the true nature of the storm's flash. Ancient voices debated the lightning. For many, it was the soft, echoing anger of the distant gods. The early Greeks felt the faint touch of electricity when silk brushed against the warm glow of amber. They saw the tiny sparks, much like the distant stars, dancing between the cloth and the stone. The mystery remained silent until the year 1752, when the answer finally drifted into the light. Beneath a summer storm, the scholar Benjamin Franklin flew a simple kite into the dark, whispering clouds. He captured the storm's breath in a simple jar, drawing the electric flow from the night sky. He proved the lightning was but a flow of energy. With this truth, other explorers soon followed. Minds like Charles Augustin de Coulomb began to trace the quiet laws that govern every electric charge. The mathematical visions of Carl Friedrich Gauss and the gentle observations of Michael Faraday soon emerged. They saw that the power of electricity was best felt as a soft and invisible field of energy. These were the electric fields. 50 years later, James Clerk Maxwell unified these invisible cosmic rivers. He wove together the electric and the magnetic, finding that light itself is a wave of energy. Light is but a gentle ripple in the electromagnetic sea, traveling through the vast and silent void. This slow chain of logic and mathematical vision leads us from the lightning to the nature of light. It is a beautiful and unexpected truth, hidden within the fabric of our glowing, starlit universe. Using these quiet methods, we have unraveled the secrets of the most mysterious and haunting phenomena. We see that storms are born from warmth, while volcanoes sleep and wake with the flow of magma. Lightning is but a soft spark between the clouds, and even the smallest illnesses have a source. We now understand that microscopic life can drift within us, changing the harmony of our own bodies. The list of wonders is endless. The most beautiful part of this journey is that knowledge evolves. From the early visions of Galileo, we move toward the revolution of Newton beneath the moonlit sky. Newton realized that gravity is a universal force, a silent thread that binds the entire cosmos together. After 2 centuries of quiet study, Einstein changed our view of gravity once again. Like shifting starlight, he saw gravity as a gentle curve in space and time, shaped by the presence of matter. The very fabric of the universe bends around energy, creating the soft orbits of the silent planets. Our understanding of the true nature of the world has grown deeper, more reflective, and more vast. Even now, we feel a new understanding of gravity on the horizon, waiting in the soft shadows. This new vision will blend the secrets of the quantum world with the grand dance of the stars. Through science, we have gathered more wisdom in a few centuries than in all the lonely millennia before. Our awareness of the universe has blossomed like a nebula, and our mastery of technology has followed. Yet, despite our many wonders and the fading of old myths, the universe remains a silent mystery. The dragons of the past are gone, but the boundless sea of stars is still filled with secrets. Despite our growing power, we have only touched the soft surface of all there is to know. We wonder, what are our ultimate limits? Can we use our technology to truly see the edge? How much of this vast, dark universe can we truly understand before we reach the final shore? How much can we know? Perhaps the greatest limit of all is the very biological system that allows us to think. We are held by the fragile patterns of life, the systems that cradle our consciousness and our dreams. Our minds, though beautiful and complex, can only hold a few drops from the infinite river of time. Howard Stephenberg claimed to read 25,000 words in a single minute, though few can truly say. In the quiet year of 2020, a girl named Emma Alam remembered for 100 words in moments. Later, Roger Viamina showed the world that he could remember 70,000 digits of the number pi. He recited them like a long, rhythmic poem, tracing a path through the infinite mathematical sky. It is difficult to measure the true capacity of the mind. We often compare ourselves to machines. We look to the computer for a metaphor. but the human soul works in a far more delicate way. Still, we can imagine our limits. The total memory of a human brain is vast and deep. It holds 2.5 petabytes of dreams, far more than any simple home computer ever could. Yet it is still a small lantern compared to the supercomputers that now hum in the dark. Our minds are gifted at filtering the constant storm of data that drifts in from our senses. Our conscious awareness only processes 50 small bits of light in every passing second of time. Within this small space, we perceive our world and make decisions that shape our shared destiny. We create amazing leaps of imagination, drifting through the stars on wings of silent thought. Beyond these many constraints, our physical forms remain fragile against the cosmic scale. We must seek nourishment and water, ensuring our weary minds find a soft rest. The longest a soul has remained awake is but a brief 19 days. Our existence is bound by DNA, drifting within a narrow window of gentle light. The mind operates within limited boundaries, and eventually, the silence returns. Our biology defines our furthest reach, even for the brightest of all stargazers. We rely on the same ancient mechanisms, where ions cross through delicate membranes. Soft electrical signals travel through neurons at a slow, whispering pace across our nerves. Gentle hormones flow through the body to maintain a quiet, inner equilibrium. Within every cell, proteins perform their silent work to store and release energy. These mechanisms are written into us, the product of billions of years of evolution. No hidden trait or chance of birth can expand our capacity beyond that range. We are cradled in a thin biosphere, clinging to the surface of our world. Or we drift in small capsules, seeking to sustain our fragile life in space. Wherever we wander, we carry our biology, and so we must ask ourselves tonight, is there a way to drift beyond the limitations of this physical vessel? The experiment was ready. The transcendent spent countless generations in silent calculation. After millennia of construction, they reached what we call a cosmic milestone. They became a Nikolai Kardashev Type 1 civilization. An array of solar panels surrounded their star, joined with vast fusion plants. They harnessed every beam of starlight that reached their distant home world. In this journey, they settled across their entire shimmering solar system. From the glowing inner worlds to the moons of distant, silent ice. Cities flourished on every planet, sending soft signals into the deep void. Endless synthetic messengers were sent to wander between the distant, glowing stars. They mastered the fundamental forces and the strange, whispering rules of the quantum. With this wisdom, they built ethereal devices that would seem like pure magic. Yet, They also met the familiar walls of the silent, waiting universe. They learned that natural forces merge at energies far beyond a planet's reach. The laboratories on their home world were simply too small and quiet. To peer deeper into the mysteries of nature, they looked to the stars. They built a particle collider the size of their entire solar system. By gathering resources from wandering asteroids and the layers of forgotten moons, they forged a superconducting ring that circled their brilliant central sun. This device held the power to touch the Planck scale and break gravity's veil. The Planck scale is where space and time itself begin to softly dissolve. Over the centuries, this grand endeavor took on an air of sacred mystery. The first trial of the Great Collider was a moment of grace. It was accompanied by grand ceremonies, long reflections, and drifting music. At last, after lifetimes of work, they felt a sense of quiet expectation. They activated the machine, ready to look into the very heart of reality. With 100 billion neurons and 100 trillion soft synaptic pathways, the mind is the most complex garden in the known, whispering universe. Our capacity to process and cherish knowledge is a gift shared by no other. Since our thirst for understanding can never be fully stilled in the night, we developed gentle tools to expand the horizons of our own consciousness. Long ago, before our modern understanding, healers faced a mysterious, heavy illness. It was a sickness that brought a deep, fading weakness to the body. They believed it was caused by wandering mists or the scent of bad air. But in the 19th century, John Snow felt the truth was different. When the quiet streets of Soho were touched by this shadow in 1854, John Snow used a simple new method to find the source of the sorrow. A soft map of points showed where the illness had gathered in the dark. Using this map, he followed the trail to the center of the cluster. It was a simple water pump standing on a quiet, stone street. With this knowledge, the handle was removed, and the illness slowly drifted away. A humble map, a gentle instrument of truth, saved countless lives that year. Technology does not need to be complex to be a guiding light. As we learn more about the inner workings of the natural order, we build stronger tools to explore the beauty and silence around us, gently reaching further into the secrets of our shimmering world. We created devices that enhance our senses, allowing us to see the unseen. We forged telescopes, bringing the distant, glowing cosmos into our quiet rooms. It began when Galileo Galilei turned a simple toy into a scientific instrument. His first lens could only magnify the world 8 times over. a power now surpassed by even the simplest pair of modern binoculars. Yet, with that soft light, he saw mountains and craters upon the moon. The moons of Jupiter and the phases of distant, silver Venus, and the countless stars that form the river of the Milky Way. With every new lens, deeper discoveries began to bloom in the dark. In the 1920s, with the help of the Great Hooker telescope, Edwin Hubble observed a single, pulsing star in the Andromeda Nebula, revealing it was a galaxy sailing millions of light years away from us. Though telescopes on Earth grow larger, reaching over 30 meters in diameter, they are limited by the flickering air of our own soft atmosphere. Space telescopes, though smaller, hold a much purer vision of the universe. The James Webb Space Telescope carries a mirror 6.5 meters wide. It folded like golden origami to fit within its silent rocket. Its resolution is 100 times sharper than the reach of the human eye, able to see the details of a coin from 40 kilometers away. Yet the most powerful vision proposed is a solar gravitational lens, using the sun's own gravity to bend and focus the distant starlight. An instrument placed far beyond the planets could see with impossible clarity. At that resolution, it could paint a portrait of a distant world, capturing any exoplanet within 100 light years of our home. At the other edge of wonder, we fashion microscopes to see the unseen. Today, our most powerful lenses rely on the gentle whisper of quantum tunneling, reaching a precision of 0.05 nanometers to map the silent dance of atoms, creating high-resolution portraits of even the smallest shimmering forms of life. Lately, computation has become our third path of discovery, alongside theory and light. We use complex algorithms to mirror the natural world and its slow evolution, watching as every small part follows the eternal laws of the universe. Through digital dreams, we watch synthetic universes drift across billions of years, peering into the hearts of stars as they fade into supernovas, observing how proteins fold together to perform their vital, quiet work. As humanity continues to seek knowledge within this vast and glowing world, our technology flourishes. Within the soft glow of our digital archives, we hold an estimated 175 zettabytes of information beneath the starlight, a staggering 175 trillion gigabytes of memory. Each passing year, our species consumes nearly 5 times 10 to the 20th power joules. And though most of this flame does not store our thoughts, we will need much more light to upgrade our current tools, gathering deeper data from the silent reaches of the distant cosmos. What is the most beautiful way to find this needed power? If we draped our world in solar silk, we could catch the sun. gathering 4.4 times 10 to the 16th power joules every second. In less than 3 hours, we could capture enough solar radiance, satisfying the energy needs of our entire world for a full year. To go further, we have two choices: catch more starlight, or travel toward the energy-rich environments of the Milky Way. To gather more light, we might follow the visions of the dreamer, the thoughtful physicist Freeman Dyson, who imagined reshaping entire worlds into a shell that cradles the sun. These Dyson spheres could capture the golden warmth, preventing it from drifting uselessly into the cold, dark void. If we transformed our world into a thin, shimmering solar shell, we could catch a small fraction of our star's total output. Though it seems minor, this tiny spark of cosmic energy is vastly greater than all the sunlight that currently touches our Earth. Such grand engineering carries its own heavy cost of energy, as reshaping a planet requires a profound and patient effort. It would take tens of thousands of years to return the light invested in turning our world into a vast garden of solar panels. Since we see no such spheres within our glowing galaxy, perhaps a wiser choice is to pack our dreams and move. Black holes offer a deep, silent home for civilizations searching for light. Their spinning gravity stirs the very fabric of space and time, allowing a clever species to harvest energy from the swirling darkness. On that scale, we could turn planets into vast libraries of data, transforming entire solar systems into quiet observatories for the stars, sending probes to the soft edges of the galactic river. In the work of high-energy physicists, we see a beautiful harmony, where science and technology walk hand in hand through the years. For a century, we have tried to gently unlock the secrets of reality. Since the 1930s, we have used invisible fields to guide particles, accelerating them to high energies before they meet in soft collisions. Searching the aftermath for the fundamental building blocks of existence, we began to peer into the tiny, shimmering subatomic world. Ernest Lawrence was a pioneer of these early cosmic collisions, creating a small cyclotron that whispered with 80,000 electron volts. After the Great Wars, these experiments grew ever more powerful. At Brookhaven National Laboratory on the quiet shores of Long Island, researchers created a cosmic collider reaching billions of electron volts, discovering a new family of particles known as mesons. Later, near the soft prairies of Chicago, the tevatron reached higher, achieving peak energies of 980 billion electron volts, confirming the existence of the top quark of the 1990s. In 1991, a massive project began beneath the Texas soil. But the dream of the superconducting super collider faded too soon. Had it been finished, it would be our greatest window into the void, Instead, on the peaceful border of Switzerland and France, the Large Hadron Collider became our most powerful tool for discovery. It took a decade to build, costing nearly $5 billion, achieving energies of nearly 14 trillion electron volts. Thousands of stargazers from across our world joined this quest, confirming the standard model of how our universe is woven together, revealing the Higgs boson and its vital role in the cosmic dance. These machines have successfully unraveled the secrets of the small, yet they also show us the limits of our current hands. Though the energies of the LHC are incredibly high, reaching the Planck length requires a much greater leap into the unknown. To prove the theories that unite gravity with the quantum world, we would need a collider 10 trillion times more powerful, bridging the gap between the very large and the very small. As we continue to grow stronger, we begin to see our own horizon. To explore further, a vast journey still lies before us. We must dream of radical technologies far beyond our current imagination, drifting slowly toward the ultimate secrets of the silent universe. Sleep now, while the stars continue their ancient and endless journey. We must expand our reach across the silent heavens, beyond planets or lonely stars, embracing entire galaxies. A fleet of 10,000 vessels drifts through the deep, spending long lifetimes weaving ideas and weighing the mysteries of hidden technologies. After exploring every path of the starlit void, the Transcendents realized no single path could lead them safely across the velvet dark. Thus, they embraced every dream. Some within their silent world began crafting great generation ships, wandering tiny worlds of soft light meant to cradle many souls for ages. Others fashioned slender vessels, moved by gentle beams from distant worlds, sailing toward chosen stars. Yet most chose a middle path, ships of modest size carrying many travelers, held in the soft embrace of sleep, resting beneath the quiet glow, while silent systems guided them through the mist. Truly, this task demanded all their strength, yet no other choice remained. The life of their home system had faded into twilight embers, and answers lay beyond the horizon. They reached past their ancient shores, crossing the threshold of a Type 1 world, stepping softly into the unknown toward a Type 2 destiny and the shimmering realms beyond. The secret to the stars was found in a small, shimmering place. Consider the hummingbird, small jewels of flight known in hundreds of forms. The smallest of all living birds. Most dwell within the lush, humid forests, yet some spend their summers in the north. Each year, as the air cools and flowers sleep for winter, these hummingbirds begin a magnificent journey, migrating toward warmer lands. Among these tiny, brave travelers, the rufous hummingbird measures only a few soft inches in length. At the close of every summer, it embarks on a long flight across 6,000 kilometers. From icy northern lands to golden shores, returning when the spring awakens. To make this miraculous crossing possible, they use a state of deep stillness, a quiet rest called torpor. This gentle slumber lowers their pulse and slows the dance of life. In this deep sleep, their warmth fades and their breath grows slow, lowering their life force by 90%. If we are to sail the stars, this state of soft hibernation will be our bridge to the heavens. Voyager 1, launched into the silent void in the year 1977, is now nearly 25 billion kilometers from our pale blue home. It drifts through the interstellar deep, a lonely whisper in the dark. Crossing the heliopause in 2012, where the sun's breath finally fades. Traveling at 60,000 kilometers per hour through the quiet night. Voyager 1 continues its long journey among the distant, silent stars, becoming one of many wanderers circling the heart of our galaxy. If a child were to start this journey aboard the ship, they would reach the interstellar dark in the middle of their life. By the time the ship reaches the inner edge of the Oort cloud, that vast shell of icy fragments drifting at the edge of the sun, that traveler would have long since passed away into starlight. For the journey takes 300 years. To reach the outer edge, another 10,000 years must pass. If the ship sailed for Proxima Centauri, our nearest cosmic neighbor, it would take 35,000 years to arrive at that distant shore. As a fragile species, we have only begun to learn the rhythm of planetary distances. Yet we are not ready for the vast oceans between the stars. The Canis Major Dwarf Galaxy, 25,000 light-years away. A journey that would take 700 million years to complete. Our current vessels only find their speed through brief moments of power, carrying very little fuel once they drift into the eternal silence. Enough only to whisper a correction if they drift off course. They may use the pull of planets to gain a silent boost, stealing momentum to glide faster through the deep cosmic river. But in the empty void between stars, this is no longer possible. The laws of the universe set gentle but firm limits on our reach. To move faster through the night requires the spark of energy. In the vast desert between suns, energy is a rare and precious light. A ship must either glide at a steady pace through the dark, or carry its own inner flame. Because of this quiet truth, we have two choices: to travel large and slow, or small and fast. Many years ago, a dream arose of a ship powered by a sun. Using the most potent forces we know, Project Orion was a vision of riding the waves of nuclear light, pushing a vessel forward on a shield of strength, gliding across the silent cosmic sea. While meant for nearby worlds, the stargazers saw a grander path, where a massive ship could reach Mars using 800 pulses, carrying thousands of tons into the reach of the red planet, or reaching Saturn's rings in less than 3 fleeting years, offering a shimmering hope for journeys to the distant stars. Yet the challenges were many, and the dream slowly faded into shadow. Perhaps the vision will return, or a new path will be found to carry us swiftly across the bridge of the night. Another quiet dream remains, the generation ship, or the celestial ark. This vessel does not seek to race against time. Instead, the ship itself becomes a floating home, a wandering world, where many souls live and grow in the deep silence, passing the torch from one generation to the next in the dark, arriving at their destination after 10,000 years of drifting. Such a journey is filled with mystery and soft peril. Yet a civilization could steadily expand through the river of stars. A slow colony might span only a small part of the galaxy, yet it would open hundreds of new worlds to the light of life. In 2017, a traveler named Oumuamua visited our sun, then returned to the deep. A patient people could wait for such a wanderer and make it a home for their journey. Turning a drifting stone into a garden among the constellations. To travel faster, we must become small and light as starlight, allowing tiny seeds of technology to fly on the solar winds. Break through star-shot dreams of ships sailing on sails of pure light, reflecting a powerful glow to push them through the velvet void. A kilometer of shimmering film, pushed by a beam for 10 minutes, could reach 1/10 of the speed of light in the silence. This would bring us to our nearest neighbor within a single lifetime. But there is a quiet challenge. The ship must be as light as a single gram, carrying almost nothing into the infinite dark. We must look deeper to find a way to truly sail home. So, how far a driven soul wander through the stars remains unknown. A few light years allow visits to nearby suns, and thousands span the galaxy. Millions of light years would carry them across the vast and ancient cosmic rivers. But despite the many silent challenges and the shadows that drift between stars, if they reach extreme speeds, the universe offers a soft grace called time dilation. We know that moving clocks pulse more slowly, drifting through the quiet vacuum, from the view of a distant observer as a craft nears the light. Time seems to slow to a whisper, woven into the fabric of the cosmos. For those within the ship, the passage of moments remains soft and familiar. From their quiet perspective, they are still, while the whole universe glides by. Of course, approaching the speed of light brings its own heavy, silent burdens. But if a culture could somehow cradle such vast and ancient energy, the entire galaxy would rest at their fingertips, like stardust in the wind. If a ship could maintain a constant, gentle pull of one Earth gravity, gradually nearing the speed of light, an outside observer would see time fade. Nearly 30,000 years would pass to reach the glowing heart of the galaxy. Yet for the travelers inside, crossing half the width of this swirling light would take only a few soft years, though it demands immense cosmic power. To truly touch the wider universe, we must slowly transform our own biology. A human life of 80 years is but a flicker in the cosmic eye. Though we pass our stories through ink and song, the stars watch us fade. We strive to preserve our wisdom for the children of the distant future. If we are to seek the deepest mysteries hidden within the velvet night and consume the vast information of the stars, we must find new ways. We must expand the reach of the mind and lengthen our fragile lives. To endure the long, silent journeys between the suns in search of power. Perhaps the path is to create systems that set our conscious thoughts free, to release the dreaming mind from the heavy prison of the physical form. This would allow a part of us to drift between the lonely stars, without the need for breath, or water, or the warmth of a home. We might build small vessels to hold our souls, or even entire communities, resting in a low-energy slumber through the long, dark hollows of space, awakening only when the light of a new sun provides the energy needed. Not through mere machines, but through a gentle, synthetic and organic harmony. Yet even with the wisdom of the transcendence, there may be quiet limits. We all dwell within the same universe, bound by the same ancient laws. We are held by the same physics, drifting through the same timeless sea. Despite our greatest dreams, the cosmos sets a silent boundary for our journey. These are the cosmic limits, and they call their last hope the machine. Generations spent their lives building it, layer by layer, across the silent void. So much time passed that the world where the dream began was lost. It vanished from the records of history, forgotten beneath the dust of time. But the purpose of the machine endured through the long passing of ages. The Transcendents had mastered every technology they once struggled to understand. They designed the machine to bridge the lonely gaps between the distant stars. They could sway the pull of gravity and create minds as deep as oceans. They were now a great type to civilization, masters of their own sun. Every capital city could drink the entire light of a burning star, wrapping it in a shimmering web of panels to catch every golden beam. But the machine was their final masterpiece, a bridge across the silent dark. They sent their eyes and their whispers to every corner of the galaxy. Yet they found no other voices calling out from the shadows of space. As far as they could see, they were alone in the velvet silence. They longed to know if the universe was made for them alone. And so, they planned to scan every galaxy in the vast, observable sky, capturing every detail and every wave of light from the distant shores, seeking enough wisdom and enough truth to quiet their lonely hearts, to know, finally, if they were truly alone in the boundless night. The machine stretched across the galaxy like a web of silver light. Robotic missions worked in silence among the far and lonely suns, turning entire worlds into lenses, antennas, and vast rivers of power. Every system became a giant eye, watching the many wavelengths of light. Each observatory worked for 10,000 years to map the silent stars. Then, it would send its data home and dissolve back into the dust. The stream of information would flow for over 100,000 years. Planets became libraries of light, and black holes powered the great thoughts. This would be the census of the cosmos, absorbing all that exists. If we look far into the future, imagining our own slow progress, we can see the shape of the wonderful engines of discovery yet to come. We could build paths for atoms to dance around the entire solar system, reaching energies far beyond what our small machines can touch today. We could place eyes in the deep dark, using the sun to bend the light, using gravity as a giant lens to see the secrets of the furthest stars. In the far future, we may capture the breath of the sun or the spinning, the energy of neutron stars and black holes to feed our vast thoughts, to power computers so deep they can dream of the entire universe. They would simulate every atom and every star in a silent dance. But despite this infinite potential, the universe has its quiet, hard edges. The laws of physics will never let us drift faster than the light. The age of the stars, the number of particles, and the slow decay. At some point in the deep future, our search for wisdom will finish. We will have gathered all the information the universe has to give. The quiet truth is, there is only a finite amount of light. In the quiet 1920s, the stargazer Edwin Hubble felt the universe slowly expanding. Every distant galaxy drifts softly away, floating further into the silent, eternal dark. Through passing ages, we learn this motion whispers of a universe that is finite. Time is our first veil, born long before the era of Hubble. The stargazers once dreamed the heavens were eternal, drifting forever through the silent past. They believed the soft starlight would linger, unchanged within the cradle of the future. Yet the Big Bang gave the cosmos a gentle, infinite age. A second boundary hides in space, for though the stars may stretch forever, the swelling cosmos creates a horizon, a soft veil limiting our reach into the distance. With time limited and light traveling slowly, we see only a fragment of the whole. We wander through a vast dark room, illuminated only by a soft and narrow glow. Because light from the furthest stars has traveled for only a flickering moment. This stillness is a light cone, a shadow where all whispers of information must travel. Within space and time, even a single beam of light wanders slowly toward its destination. It takes time to reach us. If the sun's golden heart should fade, the cold shadow would drift slowly, taking 8 soft minutes to reach our sleeping world. Should Andromeda vanish, its memory would shine for 2 million years before the silence falls. When we look across the entire cosmos, we realize a profound and quiet truth. The boundless sea of stars is likely much larger than anything we can observe. Untold galaxies and stories remain forever tucked in the deep. There are celestial secrets and distant events that will never drift toward our lonely shores. Their soft starlight and ancient songs will never reach the edge of our searching eyes. Every mystery they hold is destined to sleep eternally beyond the horizon of our vision. As the universe expands, the most distant stars are carried away on a cosmic tide. They sail away faster than light can follow, leaving only a faint and ghostly glow. This light was sent eons ago, from galaxies that have now drifted into the unknown. With each passing moment, they fade softly, vanishing like a dream into the night sky. In this ever-growing cosmos, the beauty we can behold begins to slowly diminish. The wisdom we can gather is held within a fragile bubble. Drifting through the deep, cosmic river, 14 billion years of history, and 40 billion light years in every direction. This stillness introduces a fundamental uncertainty, a cosmic variance in the fabric of all we know. Many movements in the stars happen by chance, sown from basic physical seeds. The evolution of systems is a roll of the dice. Our Milky Way floats here, with its own mass, its own starlight, and its own unique history of merging. While early forces guided the gravity that shaped the stars, those forces did not choose exactly where each galaxy would find its home. The Milky Way could have been anywhere. When we measure the vast structures and the dark energy that flows between the constellations, we must always remember this random, drifting chance. We can only visit a small corner of the whole, never measuring the total. Thus, a mist of uncertainty remains. Imagine being shown only a few cards, drawn from a hidden deck. As you try to count the suits within, you will inevitably find yourself lost in the unknown. On the grandest scale, we find boundaries, but on the smallest scale, we meet a very different kind of fundamental mystery. First, we wander through the soft mist of the Heisenberg uncertainty principle. In 1927, Werner Heisenberg, the father of the quantum world, first glimpsed this truth. At first, it seemed like a limit of measurement. To study a tiny particle, to simply look at it, requires you to bounce a soft photon off its surface. In our world, photons are light and gentle, making no difference at all. The hunters and the wild remain unaffected, no matter how bright our light shines. But a tiny particle is small enough to react to a single photon. To find its exact location, Heisenberg realized you would need a high-energy photon with a very small wavelength. But that light will gently touch the particle, and as it returns to you, you will know where it was, but lose its current path. If you use a softer light, you will not disturb the particle's peace. But the long waves mean your vision of its place will be blurred. Heisenberg knew not to have both the location and the path. You cannot measure both position and momentum with infinite clarity. But this is more than just a limit of our tools and tricks. It is woven into the very mathematics of the quantum dream. Even so, through a series of quiet debates, Albert Einstein himself searched for a way to escape this uncertainty. But each time, his gentle rival, Niels Bohr, found the flaws in Einstein's beautiful and wandering thoughts. Einstein imagined devices of springs and clocks and hidden gaps, believing this uncertainty was merely an illusion of our incomplete sight. However, Bohr looked deeper into these arguments, finding that even in the most detailed plan, the principle held firm. Eventually, Einstein accepted that our knowledge of the cosmos has limits. He still felt that the quantum description of nature remained unfinished. Within the quantum world, there is information we simply cannot reach. This boundary shows itself in the soft probability of all small things. In our daily lives, if you know the laws and the state of a system, you can predict the future with absolute, silent certainty. But the quantum world follows its own melodic rules. Even if you know everything, you can only see the probability of what may be. The equations of Erwin Schrödinger show us how to calculate these chances. They appear as waves, with every particle in the universe attached to one. These waves drift through our interpretations like echoes of reality. Where the wave peaks, you are likely to find the particle resting. Where it falls into a trough, the chance of finding it is very low. That is the most information we can draw from the quantum sea. It is a map of where things might be, rather than where they truly are. But the edges of this boundary are often very hard to discern. We usually think of these limits as something far below our experience. A hidden world we never need to worry about in our daily lives. But in the year 2019, at the University of Vienna, a group of physicists achieved what once seemed impossible. They captured the wave-like nature of a massive molecule of 2,000 atoms. Their work shows us that with the right eyes, this quantum blur can be amplified into our surprisingly large world. Finally, there are regions where ancient knowledge and information sleep. Pockets of the universe where the secrets of the architects are hidden. But they remain tucked away, waiting for the transcendence to find them. Until then, we float along the cosmic river, beneath the moonlit sky. The soft blur of the quantum world can swell, touching the vastness of our reality. Finally, we find pockets of the universe where ancient knowledge lies hidden in shadows. But some realms remain forever locked away, hidden within black holes and the fading past. Black holes are masters of keeping secrets, silent guardians of the knowledge they hold. They gather the densest information in the cosmos, yet remain whispered secrets we cannot reach. The most defining feature of a black hole is its event horizon, an invisible, ethereal boundary. It is a threshold from which nothing returns. Regardless of what lies deep within the dark, everything the black hole consumed, throughout its long, silent life is hidden. Behind this cosmic veil, you may choose to drift toward it and seek the hidden truths kept inside. To find them, you must cross the event horizon. But once you step beyond, there is no returning to the starlight. You may still receive echoes from the wider universe as distant light continues to drift in. The secrets of the cosmos flow towards you, yet you can never share your revelations. for a quiet and heavy truth awaits you there. Once you cross that final horizon, your journey through time reaches its ultimate, silent end. Within a fleeting moment, as measured by the slow ticking of your own quiet heartbeat, you are destined to reach the singularity, the point where infinite density meets the eternal dark. Every secret gathered at the heart of the black hole will simply fade away with you. Only 3 quiet echoes remain for the outside world to witness from the distant darkness. The black hole's mass, its slow spin, and its electric charge. All else is soft shadow. As for the past, our understanding of physics, and the quiet flow of space and time, tells us that the moments drifting behind us are forever lost to the cosmic river. They cannot be fully reached through our memories, ancient artifacts, or the universe's current state. We may wonder and dream of what was, but once a moment slips away into silence, it glides behind a soft, grey horizon, and what is not preserved truly fades into nothingness. Therefore, when we look at the universe, on its grandest and most vast scale, or peer down into the tiny, whispering world of the microscopic, across invisible boundaries and through impossible tunnels, within the fabric of space, there are realms in this universe that our wandering hands can never truly touch. What is the ultimate limit of the knowledge we can gather from this silent universe? Within the observable universe, there are hundreds of billions of galaxies drifting in the dark. If we could pause the expansion of space and record every single one of them, that would be the horizon of our knowledge. The total sum of the galaxies we measure. Every question we ask about how these galaxies grew must be limited by that information. Together, these distant islands of light hold countless stars, shining like sand upon a shore. If we observed every star and answered every question about their glowing, ancient nature, if we finished our long journey of looking at every star in the silent night, mapping their positions and the soft light of their spectra, we would find a wall that would be the final collection of every star we could ever hope to see. Eventually, we would ask questions that this finite sea of data could never hope to answer. We can also peer into the microscopic world to find more secrets hidden in the void, hoping to gather more useful fragments of knowledge from the very heart of the universe. Within the observable universe, there are about 10 to the power of 80 protons. We could measure the position and the quantum state of every single one of them. We could repeat this for every electron, every neutrino, and every particle of dark matter. Then, We could count every photon, most of which drift from the cosmic microwave background. These are the oldest messengers of light, traveling through the vast and empty star-filled sky. This is the light left from the dawn of time. When the universe first became transparent, each of these particles and every flicker of light carries a small piece of information. Yet, even this vast collection does not tell the full story of our cosmic limits. All particles are born from quantum fields, existing as gentle ripples within the fabric of space-time. These vibrations exist even in the stillness, whether or not a particle is present there. We long to understand the state of the entire system, the harmony of the whole universe. To do this, we must look deeper, far beyond the reach of the smallest particles. We must peer into the silent spaces between them, descending into the smallest of scales. As we gather more information from these depths, we reach the edge of all certainty. Here, we encounter the final expression of uncertainty, known as the soft quantum foam. This foam is where fields borrow energy from the vacuum to create fleeting, ghostly particles. They appear for a brief moment in the dark, before returning quickly to the void. From another perspective, the fields that build our reality are woven with a base energy. This baseline vibration exists even in the empty void, a quiet hum within the nothingness. It is the heartbeat of the cosmos, present even when the world seems entirely still. We reach this limit at the Planck scale, an incredibly tiny distance beyond our imagination. This tiny number is not just a theory, but a foundation of our physical world. It is a delicate balance of light, gravity, and the fundamental constants of our world. At these scales, our normal sense of space and time begins to dissolve into mist. Here, the smooth fabric of space gives way to a turbulent and chaotic cosmic flow. There may be secrets beneath this scale, but they lie far beyond our current understanding. Thus, the Planck length serves as the ultimate resolution for all knowledge in the cosmos. To find the total information of the universe, we can divide space into tiny Planck cells. Imagine the observable universe as a vast collection of these incredibly small, quiet units. Within each tiny cell, we can observe the energy levels of all the quantum fields, connecting the entropy of the universe to the information it holds within its deep silence. Using the formulas of Claude Shannon, we can estimate the information held within the stars. The wisdom of early pioneers allows us to see the boundaries of what we know. We assign a single bit of information to each Planck-sized unit within the vast observable void. This allows us to weigh the total amount of knowledge the universe can possibly hold. This suggests the total information of our universe is roughly 10 to the power of 120. Though this is speculative, there is a final limit to the knowledge we can ever grasp. No matter how advanced we become, we cannot break the fundamental laws of the cosmos. Even if we gathered all this data and unveiled every secret hidden in the deep, even if we searched every corner and measured everything that could possibly be seen, would we still be missing something? Is there another way to truly see the universe? The boundaries of infinity. When this idea first emerged, it sparked a quiet, endless debate. As the eons drifted by, they found no other path to wisdom, and this silent thought grew more tempting. For they were truly ancient, even by their own mysterious standards, within the vast cosmic river. The transcendents had long since left their homes, transcending planetary life entirely. They drifted across the silent length and breadth of their home galaxy, finding no other life, while shaping the stars to their own design. Now, they are a Kardashev Type 3, harnessing every distant star, yet they have finally reached the silent limits of the physical realm. No matter how advanced their technology became, they faced an invisible wall. Unable to imagine an existence so different from their own eternal state, they wondered if their minds were still bound by ancient genetic rules, shackling their perception and blinding them to the universe's true soft glow. They created thinking machines, hoping these synthetic minds could see the stars, interpreting the cosmos through a new lens, drifting beyond their own sight. But these machines were only mirrors, faster, yet reflecting the same shadows. In their quiet despair, they discovered a young planet in a lonely corner. It was a moist world, filled with water, beneath a stable sun. They seeded that world, touching it with invisible hands, across the starlight. With gentle care, they transformed a chemical sea into the breath of life. But this was not ordinary life, for they whispered seeds of wisdom into the very atoms, coding a future intelligence within the planetary dust. In time, the life upon that world would slowly awaken to thought. The architects of this plan knew not what minds would rise below. They could not see how these beings would perceive the silent cosmos, or how their own genetics might limit or expand their dreaming souls. They wondered if these creatures would find another path through the darkness. The architects drifted into slumber, satisfied with the seeds they had sown. While they sleep, they dream of the wisdom we might one day share. There may be hidden limits to the knowledge we gather from the stars. Long before modern science, humanity found wisdom and put it to work. Science is but a branch of philosophy, a tradition spanning many soft centuries. Philosophy flows through time, reaching back to our earliest, moonlit beginnings. Mathematics itself is a journey, an exploration of logic within the mind. It seeks to understand what systems might bloom in the physical world. A mathematical truth remains eternal, even if never whispered by a machine. The skeptical traditions question if we truly know the universe at all, asking if we are learning or just creating beautiful cosmic fantasies. Even within the natural world, the question remains if we can understand. It is yet to be seen if we can truly grasp the infinite. Much of our own nature is hidden, like the soft mystery of time. The secrets of consciousness and the facts of existence remain silent. Perhaps we need a new perspective to break free from our mental prisons. A quiet debate now flows through the halls of philosophy and code, centering on general artificial intelligence, a mind that can truly reason, a system that can think and create, just like a dreaming human soul. Once a system wakes, whether made of flesh or of silent silicon, they are intelligences capable of understanding the cosmos in their way. Machine minds may be different, making choices we can never truly follow. Viewing the universe through eyes we cannot yet imagine in our dreams. A new form of intelligence has appeared, drifting among us like ChatGPT. It does not build sentences in the way a human heart speaks. It remembers vast oceans of text, guessing which words should flow together. Its voice sounds human, yet it does not truly feel or understand. This stranger's mind is alien to us, yet as we continue evolving, we may create a new spirit that thinks in ways entirely unknown. A powerful intelligence might find secrets hidden deep within the cosmic river, secrets too complex to share with our limited and fragile biological minds. Even these artificial minds may be limited by the hands that built them. Eventually, even if we answer every question across every distant horizon and view the stars from every angle without any earthly mental chains, we will still face obstacles that even the transcendents cannot fully overcome. The first whispers of infinity came from the ancient mind of Anaximander, a philosopher who believed that the universe was truly without any end. Later, in distant lands, others began to classify the different infinite paths. They felt that an infinite line was less than a vast, infinite plane, and an infinite plane was simpler than a world of infinite, cosmic volume. Yet even these were surpassed by structures stretching through infinite dimensions. All these concepts were but steps toward a greater, silent cosmic truth. However, philosophers like Zeno of Elea offered paradoxes to challenge our minds. He asked, if you always walk half the distance, can you ever truly arrive? Despite these quiet doubts, infinity became a useful tool for our math. In 1655, John Wallis introduced the symbol for the eternal, the symbol of infinity, still used today to describe the endless stars. Newton and Leibniz used the infinitesimal to build the foundation of calculus. They saw the beauty in the smallest whispers of the infinite flow. Today, infinity represents a vast family of different and wondrous entities. Thanks to the work of Georg Cantor, we now see infinity differently. There are infinite types of infinity, stretching beyond the reach of numbers. Yet, even with our math, infinity still creates shadows in our understanding. The root of this confusion comes from the distant echo of the Big Bang. Our best theory for the beginning is known as the silent inflation. A moment when the universe grew rapidly within the ancient starlight. Hidden in that theory is the possibility that our world is but one. We may be just one universe, drifting in a boundless multiverse sea, where each universe has its own rules and its own unique physical fields. They possess their own forces and a beautiful arrangement of starlit energy. If we push this thought to its end, the possibilities become truly endless. Somewhere in the infinite beyond, a duplicate of you is watching now. Another you, in another world, listening to these same soft whispers. Because that is the nature of infinity. There are endless versions of us. All of these moments are happening now, beneath a different moon. This is the measure problem, where the infinite makes everything feel uncertain. With so many universes, we cannot know what is rare or common. We cannot tell what is truly unique or what is widely shared. For in the infinite, there are endless worlds of every possible kind. If you choose a single property of our own silent universe, such as the rarity of life, or the nature of dark energy, we cannot say how often it whispers across the boundless multiverse. There will be infinite realms teeming with life, and infinite desolate voids. Though complex mathematics allow us to weigh different types of infinity, we do not know which rules govern the vast, drifting multiverse. Thus, we sail within a deep ocean of silence and ignorance. The laws governing the multiverse remain hidden beyond our flickering starlight. We might gather every whisper of information from the first dawn, reaching to the farthest edge of the visible, glowing cosmos. Yet we remain lost. If the multiverse drifts beyond our reach, its existence may never be defined by the evidence we seek. The meaning is clear. One day, we may discover new physics, allowing us to drift gently from one universe to another, exploring the diverse wonders that the eternal multiverse provides us. On those journeys, we will face challenges beyond our softest dreams, visiting strange worlds where entirely different physical laws hold sway. Yet even this cannot help us measure the weight of infinity. Exploring an infinite cosmos would require endless time and boundless resources. No matter how far we wander across the silent cosmic rivers, no matter how we leap between the glowing folds of space, infinite universes will always remain hidden far beyond our sight. All we learn is but a finite spark within the infinite. This concept of an infinite multiverse may perhaps be a dream. But if it is true, these multiple realms present our limits. We may become masters of our own universe and nothing more. We may know every star within our home and nothing more. Infinity carries a weight too heavy for any soul to overcome. Thus, in our quest for knowledge among the distant stars, we face countless limits. We are bound by our own senses, drifting within the reach of our perception of the world around us. We are limited by our imagination and our ability to think. Technical barriers prevent us from seeing the micro and macro scales. Deeper limits may stem from our genetic heritage and ancient minds. But these limits can be overcome as we find new paths. We create new technologies to break barriers and explore the cosmos. Yet despite all our soft efforts and our deepest intentions, we may meet the ultimate limits of the silent universe itself. If we assume we can reach the height of the transcendence, perhaps level 3 is our final end. Sleep well, dear traveler.